Okay, let's just look at the integrations of the rational function. So when we're talking about rational function, it means that you will come across a function that is in terms of px over qx. And inside the rational functions, we will have something called improper rational function. And what is improper rational function? Improper rational function, that is when you have the degree of the p, that is the numerator or whatever at the top, is greater than or equal to the degree at the bottom, okay, or we call it as denominator. And we have something like that, okay. And look at the example that we have here. You can see that at the numerator we have x power 3, and at the denominator we have x power 1, and obviously at the top we have a degree x power 3 that is greater than the x, okay. And the second example that we have here is you have the same power. We have the x power 2, and here also we have the x power 2. Okay, when you have improper rational functions, what you have to do is you have to manipulate the improper rational functions into proper rational function by using long division. Okay, so what is proper rational function? Proper rational function, that is, you have the degree of the p, the degree at the top, that is less than the degree at the bottom. Then look at this example. At the top you have x power 1, at the bottom you have x power 2, right? Okay, and the second example that we have is we only have numbers. Numbers means that actually you have the x power 0 here, okay? So obviously what we have here is we have number, at the bottom we have x squared, and the degree at the top is actually less than the degree at the bottom. Okay. Now, when we have proper rational functions, then we will have the case of qx cannot be factors, which means that your qx is irreducible quadratic equations. Okay, for instance, we have things like this. Okay, we have this example. We have x squared plus 9 at the denominator part, where x squared plus 9, it cannot be factored. If you use your calculator, if you press your calculator, basically it will give you some answer in terms of I. You will see small I on the screen of your calculator. The second example is saying you will have the same thing happen to the second example. You cannot factor this quadratic. This is an irreducible quadratic, cannot be factored. If you use your calculator to factor it out, basically you will come across something on your screen that is showing r to I, right? Okay, that is actually referred to imaginary number that you have. Okay, so then the second type that you come across under the proper rational function is we will have qx can be factored. So if you look at this example that we have here, it's just slightly different from the previous example, okay? The previous example, we have x squared plus 9, which is actually cannot be factored, but x squared minus 9, yes, you can factor it. So we will have x plus 3, and we have x minus 3. Okay, and same thing happened to this one, okay? We only have a small difference at here, which is actually this is a minus and this is a plus. Okay, so for this example, we have the quadratic cannot be factored, but this, yes, you can factor it into the x minus 3 and x plus 1. So if we are talking about the integrations of rational function, there are some basic knowledge that you must have before you go to these subtopics. So for improper rational functions, you must have the knowledge of long divisions. You must have the skill on how to manipulate the equations. If you don't have, go and watch the related video. Once you have manipulated the improper rational functions, it will become the proper rational functions. Okay, And in proper rational function, you have two cases. The first case is the qx cannot be factored. And under the qx cannot be factored, you must have the skill, or you must have known the knowledge regarding the completing the square. You must have the skill on how to do the completing the square for a quadratic equations. Okay, for qx can be factors, you must have the knowledge about the decompositions of rational function.